Hello everybody, welcome to another stream. How we doing? So last stream we added the versioning to the encoder generator. So now in the database file of the encode, let me set these languages. So now version numbers are stored in the database file. So every structure that we have, when we add a new version, or when we put it into dev mode and complete it, it adds a new version. So we can upgrade between these different structures. Hey, Devastated. Not doing bad. Not doing bad. Yeah, I actually managed to get some good sleep last night. So, feeling quite good in comparison. But yeah, doing pretty good. Just keeping busy as normal. How about you? How's the move going? So yeah, this stream we've basically got a bunch of little bits to do, because the code has got to the point where little things need rewriting and refactoring, to support other things and just make the code base a bit better. So we're going to be adding intrinsic types, so vectors and transforms, into the encoder because they already exist outside and I cannot be bothered to have them be declared inside this system. So yeah, we might make them intrinsics. So we'll probably declare them through code inside the encoder system. Hey there, Wajilla. Welcome. Good to see you both. How are you? How's the Vulkan going? We're going to refactor the type system such that we haven't got very strict typing in the type system. Sounds pretty crazy, but yeah, we're doing that. And you'll see why in a bit. We're going to export types to the database in the order so it doesn't break parsing in the database file. Because at the moment things are out of order, which is not good. Test is used here, but it's declared here. So we need to make sure we traverse down the, it's done in an order. We want to probably put git hashes on each type that they were added in. The git hashes are added in, yeah. So that will help us with doing multiple branches in the future if we ever decide to do it. I've thought it through, and I don't need this feature, but in the future it'd be good if we had put the hashes in the database at least. And we want to add support for amending a version because you might remove the hash dev flag, and then you've cemented that structure, and you might be like, crap, I wish I had made this change. So we can do the amend and you'll be able to change the same version basically without upping the version number. But that obviously can create some breaking things. You just got to be careful with it is all. But yeah, so guess let's get cracking on some of it. So I guess we'll start with the type system thing. So basically, we've got a thing called type, then it's got type kind, and then it's got like indices to some structure index or enum index, which get you this strut type or enum type thing, wherever that's gone here. But the majority of the fields are basically the same. So I think what we should do is just make the type just have basically everything in it. It will have a union for some slightly different things. But yeah, I think we're going to be doing that. So let's make that refactor now, and it'll just make things so much better. Yeah, a lot of things get better in the code base because of this change. So this whole dev mode thing, is it in dev mode or not? I guess it'd be like the field hash or something. Hmm. Then we also want the number. This would be the git hash. Yeah. Interested. Oh no, Rogetta. Going good. Think I finally put patches on all the leaks. Sweet. Very cool. What's the next feature you're working on? I'm good as well, thanks. The move is going good. I'm pretty much in the planning state for another week. Then we'll start the move. Oh, okay, I see. Sweet. Very cool. Are you currently living in someone else's house at the moment where you're renting? So this is your first house buy, is it? Um, yes, either it's a basic type, it's a packed type, or I guess we have a strut types. And enum for enum types, and then maybe an array. No other doesn't exist anymore. Well, I think that'd be quite reasonable. So underlying type, so identifier is a common one as well. Between all the types basically, because it's like a debug name as well. All of these guys will be for enum. And then previous and next version pointers, right? The previous and next version of that structure or enum or table can now just be pointers to another type. So we can share a lot of that code that does all that versioning link up, right? It's be far better doing it this way. So effectively, let's do the old reshuffle. So is table is no longer needed. That's all been made common. Location's been made common as well. So is ident. So it's just these three things here. They're going to get used in there like that, and voila. Now array type is the other one. Element type, right, I guess that just goes in there like that. Right, this is going to be a good refactor, I can see it already. So now I don't know if I want an array of, so I think I want to make no, we will make an array of it, an array of type. But I need to type def to get myself a type pointer, because I would like to use it as a hash table. So that can point to the ones in the structure. Be pretty reasonable. Oh. These things need to be forward declared. Hey there, Siobhan. I'm just using OBS, and I've got a green screen behind me. You can see my hair. There's kind of a bit of green in it. Um, so there's a green screen behind me. I've got it blue tacked to the wall. Well, it's not blue tack, it's white tack. Gorilla tack. Got some more left over here. So I've got that on the wall behind me, and then it's got a camera pointing towards me, and I use the chroma key filter inside OBS. Now, if you're on Windows, I think you can do it on Linux as well, but it's just more effort to maintain. You can get AI powered plugins which remove backgrounds, and you don't need green screens. So if you're willing to do that, you don't even need a green screen these days. But they, involves using AI. Currently working on meshes. Can have a batched instance system where all objects only have one instance are batched with others. Oh, nice. Cool. Pretty sweet. Now, I live in an apartment right now, but yes, this is my first house. Cool. Awesome. Wait, so you own the apartment? Is that what you're saying? Or you're renting it? Nice. Yeah, mesh systems, eh? No renting. Fair play. Fair play. It's a good step up there. Get you in place now. Pretty sweet. Have you got a garden in your new place? And I don't know if this will play. This will play with animation, but we'll get there when I get there. Yeah. Meshes. Mesh systems can get quite complex. Like you can do really you can split them into like clusters and occlusion coal in individual clusters, and you know you can do variable LOD systems like nanite. They get quite complicated. But that sounds pretty cool though. Nice to just get something simple in, that'd be great. So in the type table now, I think we're just gonna have an array of types, right? Sounds pretty insane, right? An array of types in a type table system. So enums and struts are no longer separate arrays, they're just all inside this types one. So we'll bump allocate using these arrays. Same with arrays, it don't do anything as well. Then the ident to type map will give you back a type pointer, and the type pointer will point into the array of types, right? Easy peasy. So that's a bit of a bugger though. You've got to make that pointer. Good old putter. Right, that's looking good. So just got one type that has all the shared fields and distinct fields here, which should be pretty sweet. So I guess I wanted to add the vectors and things, right? So I think a vector is going to fall under being a strut, but it's going to be a built-in one. So with these built-in ones, we don't have to export them, I think. Maybe. I don't know. Well, they're never going to change. Yeah, I think we're not going to export them. So we probably want to have an intrinsic. See this basic type thing? There's a type class. Let's make another one called vector type. But then the only problem is we've got like transforms as well. And they're basically just struts, right? They're just structures. So if we make them struts, but they've got like a built-in enum, then I think that will be sensible. So I think the way we'll roll with it is enum type intrinsic or intrinsic. Hmm. How many basic types we got? We don't got Boolean. Yeah, we only got Boolean. Whoops. So what is that, 12 or something? What's 11? Yeah, there's no F16, right, that's why. There's 11. Yeah, so maybe we can say you want to be able to vectorize those, isn't it? Um, yeah, so you could probably vector. Yeah, maybe let's have a thing where we say built-in. So if it's a built-in type, we just skip it. Basically, yeah, should be alright. Right, so let's roll with that. So let's have a think. It's missing Boolean. Cool. Let's keep going. Some snake case function, which I'm not sure if we use that, to be honest. Or we might use in the generator though when we write that. We'll keep it. Type equality. So this is now changed. Yeah. So checking if two types are equal, we used to get the strut index. Right, but now we might not need to do some of those merging codes then because of this. So inside the strut side of things, you say the strut fields are equal, and we do end up hashing. So to make this equality check quicker, we could hash. Right, this gets a bit complicated now. So when you're saying if two types are equal, maybe you just compare the addresses. Yes, when you say merge, when you're merging from one type to another one, you're just finding the identifier and simply just mapping it over. So, right. Right. Okay. Interesting. So maybe we don't need the type equal anymore. What we should end up doing is when you take one type from the type table in the encode file, Yeah, I'm not sure what that merge type was, what I was doing. Right, just finds the ident. Goes over all the structure fields, in this case, and remaps. Right. Yeah, so maybe you just need a way to look up the type from... Let's catch up with chat for a sec. Yes, there's a garden, but there will be... That would be for the wife to handle, as I hate gardening work. I can cut grass and trim the hedge of trees, but no planting of flowers. Yep. Yeah, I get what you mean. Our garden's currently kind of a mess because they messed up the garden, and I still need to ring them up and get them to come out and redo it, because when we stood on it for the first time, it all sunk. But they keep sending people out. I've sent 5 people out, and they've still not sorted it out. But yeah, I just mowed the lawn. We had these like weird plants that they put in out the front, but I just ripped them out because they're just effort to maintain. Yeah, we're not really much garden people, to be fair, but we like having the garden and using it though. You know, having barbecues and things. That's about it. I wouldn't want to plant flowers. Too much effort. It seems like if we pass it from the encode file and then we tried to move it to the encode database file, we would have kept... Right. Yeah, I think this code would have broken. Okay, we're going to just get rid of this function and just pretend it never existed, and we'll just handle the new problem. Right. Okay, it's fine where we're going. Right, so this type equal thing also goes away, because what I'm thinking about doing is when you move everything from the encode file and move it over to the database one, because you've merged it all in, you just compare the 2 pointers, and if they are equal to each other, they're matching. So we will deduplicate the types. Type string here, that's cool. Base string. Right. So now, effectively, right? You pass in the type pointer. So the string is going to be just ident. Now the array. So I guess with the array, what's it, the base string, isn't it? Type array element type. All seems pretty reasonable there. What else has got to change? Type string. Right, so this one. Huh. Why is this all following through to here? Painfully wrong. This line should be return type identifier. Yep. Now the rest of them. Right, the number of elements goes in here now, so it's A. So that'll be type array. Cool. Right, anything else here? A few more of them here. Cool, that's looking good. So now we're getting to the actual parsing code. This is parsing a number, nothing changes here with this refactor. Parsing a type. These things are going to be different. So maybe they need to be an enum. Yeah, maybe we'll make an enum then. So maybe we'll call this like parse intrinsic or something. And so I think what we'll do is we'll have that intrinsic type enum. It's going to be a bit silly, but it'll be cool. So I think we'll be able to so it's basically a copy of it, but with more things. So I don't think we have Boolean vectors anymore. I think I removed them. So we will be copying all of those a few times. And we'll be adding times 2, so vector 2s, vector 3s, vector 4s. Then we'll also be having 1 or 2 more for like a matrix. Matrix 3D. We haven't really got 2D matrix yet. Well, we have it, it's in the UI only, and it's a special one. Transform 3D, which is a slightly different one. It's called the components individually. So if we just so now with this intrinsic type thing, we should be able to we can make a string table for it. Then we'll just for loop over it and then return. You know, it could really be hashed, but it ain't the end of the world. We could hash it at some point. Right, so intrinsic type strings. Just got to lowercase everything. So it'll be like that one. Pretty good, except for these ones, maybe. Transform 3D. These are capitals. Then we have a gander core shared. Lowercase d. Cool. Yeah, so that's the lookup table. Basically, be pretty easy in the parsing code now, just to loop over that, rather than having all those silly if statements. And, you know, in future we could just pre-hash it, and then it just becomes a hash compare, or maybe we could just hash it. We could pre-hash it at boot. So we'll make it, you know, we might as well do it. U64 string hashes, right? But we'll populate at the start of the program, and then it'll just be a case of scanning those instead for equality, rather than scanning all those silly strings, right? Yeah. So in that parse type. So I guess we can do that now for a bit of fun. Initialize it. So in the main, the first thing we do is we do a for loop over all those intrinsics. Intrinsic count, and we simply just fill in that global. So intrinsic type string hashes. I equal core fnv hash 64, intrinsic type strings I, and then string len something like that. It should be a little bit more complicated than this, to be honest. We should put the yeah, hang on a minute. Got me some ideas. Core string from a C string, so there's a length in it as well. That's all it is. And we've got a hash function for this already, so it's like core string hash string like that. So there's an fnv hash on it, and kabam. So they're pre-initialized now. So when we do the parsing code in parse type, I think, right? We used to have a thing called like parse basic type. Wait a minute, I want to do one quick safety check. Static assert intrinsic type bool, no, f64, that's the final one, is equal to basic type f64, right? Basic type well, I could be explicit about it, right? Maybe I could be explicit about it here. So we just do something like this. Basic, you know, sounds pretty ideal. That way, if we insert any new ones in, it should kind of be all right. Yeah, it seems to make sense. Well, that'd be super cool. So back to that parse type again. I think this function can go now. This parse basic type. Because this one is, right, it's used in the enum underlying type actually. Yeah, what about that packed type? Is it used in here? Unpacked type. Oh, right. I see. Right, that's of course pretty easy to do. Yeah, so we can still do that. Let's delete this. No, we'll change it around. So type parse intrinsic. Yeah, so you throw in the ident. You do a lovely for loop over all the intrinsic types. and we simply just say if intrinsic string hashes, you get a hash of the string, and that ought to be good enough. Core string hash ident, and if they are equal, then we'll just be like, you know, they're the same. 64, that's right. So we'll then say return. We're going to look in the type table. It could be any type table, but type table, types indexed with the intrinsic types. So all intrinsic types will be the first set of types in the type table. Yeah. So that's how we'll do it. We'll pre-reserve them when we initialize the type table in a bit. Let's just get that all working. Am I building an engine like Unreal Unity or Unreal Engine? No. It's going to be built specifically for this game or a set of games. It's going to be like an RPG-like game. We spent a bit of time trying to find some alternative way of rendering. So we've got quite a lot of stuff already, to be fair. Hang on a minute. That's the one. Be good enough. Yeah, so we got a ray traced rendering system with ellipsoids. It's a bit glitchy right now. And we've got this sort of entity system. And what you're seeing is there's a bunch of these regions where the entities are in, and they're sort of, when they're in that region, they're next to each other in memory. So searches on neighbors is quicker. But yeah, we've got like PBR as well, and we've got like some. Oh, got too much run that way. We've got like a texture viewer as well. We can take screenshots, and yeah, see. Oh, ain't good. Yeah, we can look at textures and things, debug things. This will work right now. We're currently working on support for editors. So we're building a way to serialize and deserialize structures to text files, to packed in memory, and so unpack and pack stuff in memory to kind of like code generate this stuff for us, so we don't have we're not running over these sort of like type information structures. It's going to be mainly code generated. So yeah, we're just preparing for actually building an editor, because we've got this very sort of custom rendering thing. You know, I've not fully got there with it, but I have an idea of what I want. You know, we've got a bit of PBR, we've got these ellipsoids and stuff. So we're going to need a way to actually make content. So over the next sort of 8 months, we're basically working on an editor. So we've got a little to-do list. Thank you, appreciate it. Yes, there's a game tech plan video. You can go watch it for more. But so we've done the entity system. We're doing the decoding and encoding system, so we can basically have a way to create assets, right? Saving them and loading them and actually preserving them. And then we can get to doing a few more little things before we actually make some kind of editor. You know, so we have to make levels and materials and entities, stuff like that. All with inside the game, save out and load. That's going to be cool. Yeah, that's what we're working on for now, and then we'll get back to doing some rendering side of things. Should be pretty sweet. Why have I got a few things open? Weird. Do you think building a very simple engine like Unity, but not in the power of Unity, would be hard? I want to start it. Well, you know, the thing is, like, when you say build something simple, like a simple version of an engine like Unity, it's difficult to know what you mean, because I guess you mean have an editor and it's like a 3D game engine just for yourself. You know, you can definitely build one of those things. I would say you're probably better off building it in stages, right? Building it for a type of game, and then when you want another game that you're going to work on, you're extending it to support that new game, right? Um, you know, there's nothing wrong with building engine level technology and reusing it for another game. And there's nothing wrong with building your own editors, right, for your games. So I think that is maybe achievable, but you just not got to try and build the whole engine before you build a game. You know what I mean? So just build the things you need to work on the first game and make sure the first game isn't too complicated. Or if it is complicated, have a plan for getting other people to help out. You know, so that's what I would probably recommend if you wanted to do something like that. The thing is, just build the things that help you make the game, if you know what I mean, right? There's no point building a big old editor if you're not really going to be using it. So yeah, build things to solve problems, if you will. But yeah, if you haven't done any 3D yet, I recommend building something for 2D, right? Get going on 2D, build your editors for 2D, get learning that way. Yeah, so looking for intrinsic types is now going to be like proper quick. Going to be great. So parsing a type needs to return a putter, because type by value should only really be inside that type table array. So this is all gonna be rejiggered. Exactly, that's why I said very simple engine, because I'll put in it just important tools only. Yeah, exactly. But yeah, I wouldn't try and aspire to be like Unity though. You know, they're doing their thing, do your thing, right? We don't need more copycat solutions, right? We need newer ideas, right? But yeah, building a game engine is cool. I highly recommend it. We need more people doing it. You know? Because the more of us there is, the more jobs there are out there for people like us. Right? The more of us there is, the more pressure there is on people who make APIs for us to make them good. The less of us there is, the more they can just be like, oh, we'll just give it to these few engine developers. A bit like operating systems. There's like 3 operating systems, and the hardware people just, you know, go, oh, the kernel developers will just patch it in kernel code. So, you know, or they just, you know, make a driver for Linux and Windows and they're done. And it's a very complicated driver. So the more of us there is, the more pressure it puts on people who make APIs for us for them to be good. So yeah, this is intrinsic type. Right. So if you find the intrinsic type, you can parse it a bit. This can make it go packed, basically. Yeah, so we want to know if it is a basic. Hey Lupo, how you doing? Welcome back. Type is basic. Type. Return type. Oh, I need the type table in it as well. So much typing when I say type. Ugh. Type table. Types data less than basic type count, because they will be at the start of the array. It's going to be good. So in that parse type function, which we're trying to bring over to the new way of doing things, right, we're combining all types to just be in one structure. It's going to be amazing. Gonna be beautiful. So we've got all these shared fields and just the different fields here. So no longer do we have different structures and different arrays, it's just one array of types. And it's gonna be amazing. So if it is a basic type and we don't have this, we'll just return the basic type. But this means it's a packed type. Bum bum bum. So to make it a packed type, what you need to do is fish out the basic type. And then you need to zero basic packed. Sorry, type packed. And then get going full ham on it. Hang on a minute. That's going to mutate the type in place. Right, I've got to allocate a new one. Hang on a minute. Right, then this line will return type. So we need to have a way to create a new type. That's not going to be too hard. Don't worry about that one. Type create type init, pass in the type table, type pointer. Call stack push type table types. Alright. And I think we're going to zero it. But I think there's some more things that we would need to do. Excuse me. I will definitely put a type kind. Because you'll know that every single time you do it. Right, I think that's all the fields. An ident. No, you do that later. So here you make a new one. You extract it out, type equal type init type table. And this new one is going to be that sort of like type kind packed. So this is when we do those packed types. We put them in brackets. You can say B, the number of bits you want to pack it down to, then the range. And it'll do all the auto packing stuff. Yes, that's great. Then this is where it searches for an existing type with that name. But it's quite easy for that one. How's it going? Not going bad. Yeah, things going pretty good. I actually got some good sleep yesterday, so somewhat more awake than normal, which is good. Yeah, things are going alright, just keeping busy. But yeah. How about you, Lupo? Ever use get queue checkpoint data and set checkpoint? Yeah, that's the NVIDIA extensions, isn't it? So you get it working with Insight, right? Or is it Aftermath? That's right, isn't it? Yeah, I've seen them. What's your exact problemo, Sully? And how are you? Type is equal to. Now there is a thing to say find, I think. Type table ident to type find. Yeah, returns a pointer. Got a deref it in it. Oh, it's one of those things where, damn it. Double pointers. So effectively, right, we have a hash table where the value entry is a type pointer, but the hash table API returns as a pointer to the entry, right? So it's a double pointer. So we need to say, if the entry exists, return to me the dereference of that entry, right? And actually get the entry out. Whereas this one goes, well, it doesn't exist, so just return null. But yeah, just the way of doing things. So when you store it in, you store it with pointer. So these need to be a bit higher then, really, thinking about it. Yeah, I was just writing this code here, eh? No. Right, maybe this should be called like type table. I don't know, type in it. I don't know. So that'll do for now. Let's type pointer ptr. Nice. Right, so we've got this function here, this find function, which is the one I was looking for. In the parse type at the bottom, after we tried to parse all the basic intrinsic types, what we're looking at doing is basically going, you know what, just find it in the table. So we'll look for like struts and things basically. So we'll go type table and then the ident. Right. If we find it, return it. If not, error. Say it's unrecognized. And voila. Cool. Right, that's looking good now. We're getting places. So type table merge. This is when we've got the encoder file that we've parsed. Crying out loud. So yeah, it just looks like a C file, but we've parsed it. And then we've parsed the database file, which looks very similar, but it's got all the types in for the history of all the types. And some other extra information. And we merged the two, right? We merged this file into the database, and then we save the database back out. So this is what this merge function does, and it checks for like if you've changed stuff that you shouldn't have changed and errors and stuff. So I think we just go over all the source types now, and maybe we should skip. Wait. Did I not fill in all the things up here? We'll get back to that one. We didn't do this one. This is going to be the fun one. So initialize the type table, get to put all the intrinsic types in there now. Getting unresolved external symbol when I try calling them directly. Tried using the instance proc to load the functions when I call them anyway. But yeah, they're definitely they are instance functions, aren't they? Have you initialized? Do you have to initialize aftermath in your code base? Have you got aftermath in your code base? Is that what they need? Yeah, this is the main reason why you want to use them, right? Because if the device returns a device lost, you can still call this function, basically, isn't it? I think that's one of the advantages of it. Yeah, I think you might. Does this require like aftermath? I don't know if it does. Maybe it doesn't. I think there's a tutorial on the NVIDIA site for these things. I remember seeing it. Maybe it's aftermath integration. I think there's somewhere like here. Oh, this is all in VKCPP. Ugh. Wow. Anyway, they've got. Let's have a think. Is this right? Yeah, so if you can decode this, Sully, maybe this one will give you help. Yeah, you can translate the C++ API to the C API. It's just a bit silly they use the C++ one, to be honest. You can translate it. Like, it maps one to one. You've just got to realize that it's in the VK namespace. It's just a load of crap that they've put on top of Vulkan. And it uses destructors. Yeah, I don't know if this is correct or not. It looks alright. You got your own functions, right? That's a pretty standard way of doing it. Not sure why you got that line here. This line shouldn't be here, right? This vector. I don't know. That shouldn't compile anyway. But yeah, calling it second time makes sense. Run it throws an error, does it? And the pointer exists. But yeah, I think it's in the is there like a user guide for it or something? Integrating aftermath. Blinding white screens. Yeah, maybe it's on that Git repo thing. Yeah, aftermath song. Maybe it is just this one, right? Have a look there to see what happens. Maybe that will. Yeah, that's all right. Makes sense. Hey, cool game dev. How you doing? Welcome, sir. Welcome, welcome. How are you? Right, we're gonna have more than 10, 24 types, ain't we? 4K or 64K ought to be good enough. Yeah, so I reckon, right? This is where the fun begins. So we're going to put all the intrinsic types in here. We're going to go full ham. So with intrinsics, right? What do I want to do? So we want to go over all the basic types, put the basics in, then go over all the vectors, right? Yeah, put the vectors in. So I think we can, you know what? And maybe we should assert it, something like that. Yeah, I don't want that in there. Yeah, so the assertion will be at the end. We make sure that type table types dot count is equal to intrinsic count. And if it isn't, we've clearly not done it right. So more intrinsics. Okay, we'll say like the same number of intrinsics has not been initialized. We have not initialized all of the intrinsic types. Oh, okay. We have either initialized more or less than the intrinsic type enum has. Alright, that'll do. So we'll go over all the basic types, all the B's, and this idea is to basically go right type star, type, type init, passing the type table. What is the kind? It is a basic type. Then we simply just go right so we can set the basic to be B. Then I think we can set ident as well. That would be pretty nice. Do we have the array still? I still think we did. Yeah, basic type strings. So we'll be able to use that and core string it. Just like that. Right, so there are the basic types. So like bool, int, and stuff like that. The next one is vectors, right? So for vectors, we want to go over the dimensions, the number of dimensions, and the number of basic types, probably skipping Boolean. Four dimensions, from 2 to 4 inclusively, right? This time it's going to be a vector 1. So it's actually just going to be a strut. And we're going to manually put in all the fields. Wait, I'm doing this completely wrong now. No, it's alright, it's going alright. So I think we need to do a sort of like a string format. You know, throw in the allocator. Basic type string multiplied by a number. And that number is the D, the number of dimensions, right? Yeah. So that'll get the correct identifier. Now we just need to make the number of fields. So it's like it is a structure. So there's like a number of fields, you know, that's equal to the number of dimensions. Then we need to actually allocate the core stack push many table struct fields number of dimensions, and we simply just go over all the fields and fill all those boys and girls in. So we'll fill in like a type, which is going to be that basic type thing. So we should be able to prefetch that. So, Sully, are you saying that this this pointer here is not null? So you're saying that this vk get q checkpoint data, that's not null, is it? Have you also done the extension for it? You say they return null. Have you checked for the extension for it? This extension here. Like, you got to check for that extension. There is a thing in the header file for it. This extension name. Have you tried looking for that extension and enabling it with your Vulkan instance? So when you create the instance, you pass in that extension, you done that one? And these are instance, right? No, these are device ones. Are they? Or are they instance? Are they device? Because it comes from a command buffer, which means surely the device pointer might have to... These might be device extensions. What are these? Yes, a device extension is when you create the device. So you would need to use the VK device. What's it called? Device function pointer. No, what is it? Get proc address. This one. So yeah, the device. Make sure that device extension, Sully. Yeah. Give that a go. That should fix your problem. Right, so we need to fill in the type. That should be the basic type. We'll get that. So that's already initialized here. So we should be able to say table types data B. Right. So that'll be to the basic type field No default values, identifiers. Yep. So you can get your X, Y, Zs and Ws. So for that, we could probably just switch on D at this point. So if you're 0, it's an X. So I could have just made it parse these things, and just trusted, had them redeclared. But, maybe this is less code and it's not, people can't edit them too easily. I don't know. Pros and cons to everything, right? Field, what else? Field is hexed, is removed, location, and that should be all right. Sweet. So I think that's the so there was another field that needed to be done. It was this ident hashes. So we should really fill those in as well, because we use those when we might use those in the future. When we do our encoding in memory structures, where we can pack structures down. I might want to have a way to pack the vector down, so I might need to have search over those fields or something. So we'll quickly just do those. They're quite easy. What the shoot is this complaining about? It's not a type pointer. All right, corrected that. Anyway, yeah, so then we say field, type strut field index core string hash field ident. That'll do. So we're nearly there now. There's just 2 more intrinsic types, and those are I think we should have a way to get a basic type as a function and a way to get a vector type. And then because the matrix and transform we need ways of getting those, and you'll see in a second. So type table get basic. So that's just it's this line here. We'll simply replace it with this function. Like that. Then the other one is get sort of like a vector type. So number of dimensions. Dims is greater than, okay, 2 is less than or equal to dims, and dims is less than or equal to 4, right? Vector must be 2 to 4 dimensions. So there's a bit of maths we can do to calculate that. It should be basic take 1, since you cannot have a boolean. Basic must be not equal to basic type boolean. Vector cannot be boolean. So I think the bit of maths is take 1 times by the number of basic types, take 1. Then you probably... Wait. What am I saying? Number of dimensions, take 2. I think that's right. Plus, I think that's the bit of maths. So maybe we'll just say intrinsic type. All right. Because that's the enum it ends up being. So let's just double check and make sure that makes sense. So when you have dimensions of 2, so you're vector 2, you're saying take 1 to be 1 multiplied by the number of... Nah, I think you got to do take 2. I think that sounds reasonable. So from the intrinsic type enum, the intrinsic type enum starts with basic type count, right? So the first set of enums entries is the same as basic type. We basically inherit this enum. So the rest of them after that don't include Boolean, but they repeat, right? That's why we do the basic type count take 1 when we do the multiplication, and then we offset by the final one. So I think we still could be wrong. No. So what we're saying is, so if it's a vector 2, we do dims take 2, so it'll be 0, multiplied by this, so it'll do nothing. Then we'll add this, right? So then we'll start on U8 times 2, and then we're adding based on the basic type take 1. So this is a U8, which would be 1. You take 1, it'd be 0, so it'll just stay where it is. So that seems alright. I'm just double checking this multiply thing again. So if this was a vector 3, you'll be left with 1. So you offset by, yeah. Okay, that seems alright. So we've got a way to get a vector type now. Pretty nice. So let's fill in these other types. So if we go to our core shared, we have a matrix 3D, which is basically it's a column major 3x4 matrix with an implicit 4th row at 0, 0, 0, 1. So it's 12 floats instead of 16. So I want this to be built into the encoder system because it probably is going to get used in there. So yeah, we'll just repeat this, right? We're going to have an array of axes. So X, Y, Z. Maybe we'll just label it X, Y, Z. An array of axes and then the translation. So we'll just put the type information in here. We'll do another one like this. So we'll get the vector type. That'll be type vector. So basic type float 32 and we're vector 3. So the way I think we'll do it is we'll make a new type. We'll just call this one a matrix matrix 3D. Yep. And the number of fields we're going to have is probably 2. We have two fields. One is an axis with a type. Crap is this complaining about? Oh, right, okay. That. Yeah, so all we need to do is instantiate the two fields. It's not going to be too difficult. So this one is going to be of type. Now, it's going to be an array. So we've got to make an array of. Now, the problem with the array ones. Yeah, I wanted every one of them to be distinct, you see. So comparison would have just been via the pointer. So what could we do? So with arrays, I think the problem primarily comes from like if we want to deduplicate a type. Hmm. Maybe I do need to bring that merge function back we used to have. Yeah, maybe. Hmm. Yes, how will we get these to be deduplicated? Main question. So let's go and look at the actual files. So what happens is that this is the one that we parse second, I guess. And this is one that the user edits directly. But then there'll be the database file, which looks basically the same. And it just has all the past ones in history with the version numbers and stuff like that. So when we merge the types over, we just take the name and we just get the one with the latest version, and that's the one that we merge it into, kind of. So if you have a new field which is an array type on the structure and you're merging it over, an array field is special because an array field could be a variable length array, meaning that the types probably will never be the same. The types will probably be distinct a lot of the time. So when you're checking for type equality, why was we checking for type equality in the code? What was the reason? Right, so if types they have to match from, right. So basically what we want to say is if the types kind of match, right? They both have to be arrays. You know, if they're arrays, it doesn't matter. Ignore that bit, but make sure everything else matches, right? So if it's an array, you can have arrays of arrays and arrays though. So I guess what you want to do is tunnel down. If they're just arrays, you just want to make sure that the element type is the same. So you can just, yeah, okay. So I think we'll still need a type equal function to say, make sure it is equal except for the array part of it. Kind of. I don't know. Or we just deduplicate the array part. So is there a way to deduplicate this? We could hash it. What are we trying to do? So if it's an array, you could say, well, if the VLA ident is the same, VLA field index, it's just doesn't seem like it's possible. Yeah, so array types, I guess they're the odd one out. But the packed types are never the same either. So the packed type will need a memCompare on it. Yeah, we'll need to bring back that type equal thing, which I nuked from the code. Right, can I quickly get hold of that somehow? It is in the it is in Git though. I could just get it out of there. It was really long ago. Let's just put it back. Yeah, let's go and get it out of Git. We'll just copy paste it from there. Yum. Right, we'll get out of there. Git diff scripts encoder generator. Right, somewhere in here. There it is. Ta-da! Just gotta fish that out. Pretty nice refactor. It's taken a while. Damn these spaces and 8 tabs. Well, living, what is all of this? Oh, okay, it's ANDed. Right. Right, this can work. It's just gotta give it a bit of a rework. So if the kind is not equal, it is a false. If it's basic, sure, I guess we can get basic. If it's packed, we'll compare the packed thing. If it's a strut, we're going to be, or an enum or a table, we'll be like, right, you guys are basically declarations. So if the pointers match, then you are the same thing. Right? Because they're declarations. Arrays, these guys are going to be a little bit different. These guys are going to be like a array. The element type has to be the same. Yeah, that stuff might be a bit, maybe not the VLA field index, but definitely the VLA ident. I'll put damn underscore in it. And then make sure that the element types are equal and recurse down. Right, okay. That'll do it. B array dot. There we go. Okay. So what? Oh, okay, they're already pointers. Nice. Right, so we will need that sort of merge function back that I used to have, I think it was. But it'll have to be slightly different. That's okay. So let's just carry on with this init thing. So now we know arrays, those don't have to be distinct types. So we can just create as many of those as we want. So with array types, so I want to make an array type here for this matrix 3D thing. So what am I trying to do? So I'd like to fabricate a new type. Array type. I would like to set the array element count to 3. I'd like to also set the element type to be the vector type. And then the rest of it's fine. So field type is equal to array type. And then where we've got the identifier, where have we? Field ident. Oh. Equal core stringlet axes. Axes, did we call it axes? Oh, what was that button? No. Ah, G middle. Oh, that ain't it. Okay. It was G what? G center. There we go. It was just axis rather than translation. Okay, so let's copy that. Let's run out encode because we can. Right. And then the hash is 1, right? Cool. One more field after that. That one's going to be the translation one, very easy to do. It's going to be equal to the vector type that we fished out, then translation. And voila. Right, so there's one more intrinsic type, and then we can move on to just carrying on with the refactor using this new type system thing. And that one is the transform type. This one just has translation, scale, and rotation as separate components, if you will. So they're not all combined into just a bunch of axes like a matrix is, right? So they're separate. So translation, scale, and rotation. I just forgot we haven't got quaternion in here yet either. We need to put quaternion in. Right, let's do quaternion first. Hey, enumerator. Or enumerate. I'm not doing bad, thank you. A little bit, a bit of sleep. Quaternion. Yeah, I had some better sleep. Work's been pretty cool today. You know, yeah, just keep him busy. Exercising well, eating well. I've been keeping to my diet for a good while now. I've been taking lots of I've been kind of eating quite healthy as well, so things are just feeling quite good. I managed to completely quit sugar basically. I'm no longer a slave. It was so damn hard. Took me 7 years. But yeah, no longer a slave to carbohydrates or sugar anymore. They're all gone. So I'm feeling really good. I don't have like energy crashes anymore. Just consistent energy. If I need a bit of a pick me up, I'll just have a bit of caffeine. You know. Glad to hear it, man. I was looking forward to streams. Thank you. Appreciate it, sir. Appreciate it. Yeah, looking forward to doing stuff too. I always get myself into these damn complicated systems, and I'm just like, I want them to end. But I also want to pay attention to make sure it gets completed well enough so I'm not coming back in the future and being like, I need to, you know. It always gets like that with programming. You start something, you're like, this is gonna be amazing. And you get to like the tail end of it and you're like, when will it end? But we're getting to the point where we can code generate stuff very soon. Dealing with some damn refactor. But yeah. Alright, we need to do a bit of a quaternion now. Yeah, get into the weeds and just look for a way out. Me right now with some assembly. Assembly, eh? What you doing? What you doing with assembly these days? Or I need to do a quaternion. Where I'm hard coding it again like this, cause I think my quat type is a bit of a XYZs, XYZW, ZW, English, bit of a quat. Four fields. Four fields. Four fields. Four fields. Then we go over all the fields. XYZ. Basic type is a float. Hey, why am I using that get basic? Make it look easy. Don't do this. Oh, is it type table get basic? Right. Right, so the basic type is float. Right, then just go over all those, chuck them in there, and jobs are good. So, yeah, right, so we've got the quaternion now. So we have a way to get the, we should have a way to get an intrinsic one as well. Right, get intrinsic. Yeah, I want this. I don't know what happened there. That one. Right. So for this new type, this transform one, it's got 3 fields. We need vector 3, and we need a quaternion. To make a new one called transforms, another built-in 3D, 3 fields, 3 fields, and 3 fields. Now we just fill them in manually. Effectively, they're like this. Right, I think it's translation. Hang on a minute, let me get it right. Get out of there. Yeah, translation, scale, rotation, all separately. Right, translation is vector type. Scale. Yep. And the final one is rotation, which is the quaternion. That's the quaternion type. And rotation. Right. So that's all the intrinsics done. So now we've got the intrinsics getting initialized. Why is D not declared? Ooh, nice find. Cool, so that's all the intrinsic types declared. Now they're in the... Ooh. They don't need to be in the ident. Ah, they do. They need to be in the table. Get that in there. See, if you did an init... yeah. For crying out loud, don't do this. Ah, yeah, type table. Table is declared after. Type ident type. That's all the vectors, all the basic types, getting the type in the ident table. So if we ever try and declare something with the same name, it will complain. Quaternion as well, followed by this matrix 3D thing, followed by this transform 3D thing. Nice. Cool. So now we can get back to actually like have a look. Ah, the format code is going to kind of change now. It's just format type. Interesting. Right, so the context aware formatting might have to change a bit. That'd be cool. Yeah, so now we're just getting back to dealing with the fact that we've changed the type thing. So it's just one big strut that does everything, rather than having these different struts with basically the same fields. Been reading through Agnifog's stuff on optimization, and it's been a lot of fun, learning a lot. Pretty new to x86 assembly and the bigger registers. Most of the stuff I usually do is very simple, chucking stuff around and juggling registers. Right, okay, cool. That's great. You're actually getting in there with that. That's cool. Do you mind dropping a link to that? That'd be interesting. I'll be interested to look at that. Yeah. You know, it's kind of interesting how many registers there are. You know, there's basically like kilobytes of registers, you know, and we don't even really use most of them. except for when we do like a mem copy or something and the standard library uses it and you've compiled with the right stuff, or if it auto vectorizes or whatever, right? You know, so it's kind of a bit of a shame how unwasted that hardware goes. But if you go and program on GPUs, your shaders all basically use SIMD like intrinsics under the hood, right? The GPU shader cores are slightly different, you know, or they are quite different to, you know, CPU cores, but you know, CPUs have that similar sort of thing where they can do single instruction multi-data, but we don't have a good programming model for it. You ought to include a meaty header file in all your code, and then like think in 8 wide ways. But it's pretty cool though. You basically get like, if you do it well, you get quite good some quite good gains. Of course, man. Here you go. Rightio. Just get in there. PDF. Yeah, definitely. It's not even the fact that it's poorly optimized. Like, it is anti-opt. You know, software is anti-optimized. Like, there's just so many layers of abstraction, and people don't really think about how their code kind of like the complexity of their code to run, if you will. You know, when people write code typically. You know, it's only people who really work in C++, maybe other languages, right? You know, and maybe everyone in C++, I don't know, really understand what the machine actually does. This is cool. Take a look. This should work on x64. They talk about the X and the MM and the YMM registers. That seems pretty modern to me. Yeah, it's updated to 2023. That's cool. Well, I'll take a gander. If not, I'll post that in the Discord. And I'll say you've shared it. Thank you. Right, there's some good stuff in there. Right, let's keep going around the diagnostics. This is where you do it in Helix. Apparently, is you don't compile it. You just use the diagnostics from the LSP. Right, type table merge. Right, we said we was gonna get to this one, and then I got distracted in the intrinsic types. So we're back here again. So this is to do with when we've parsed both the encoder file, which the user edits their types in, and then we've also parsed the database file, which stores the history of everything. They basically look the same, right? But they've got some extra explicit things in here. And they have the whole history. So now we don't have separate things. We basically have one. Right. So I think we want to loop over all types that have been declared and merge them in. So we only care about declarations. Source type. Source type. So source type, if source type kind. Maybe we can switch it. We could also say like is declaration, and that makes the code a little bit more readable. Yeah, maybe we do that. All type kind is declaration. Is decal. Hey. Type kind. Kind equal. Yeah. We'll switch it. Right, basic is not a decal, or it's not been declared. But table, strut, enum, those things get declared by the user. These ones are all return false. This makes the code a little bit more readable, I guess. What did I do? Right, so here we're going to say if not decal. Then we're going to continue. So we go over all the types that we find in the encode file, and this is going to find the destination type. If there is no destination type, so we look for that identifier. If it does not exist inside the database, we are going to simply add a new one. So what we need to do is do a type. We'll just append it. We should just be able to store it in there. So we just go push. Maybe we'll do the type in it. Yeah, DST type equal type init destination type table. We don't really care what kind it is because we're going to dereference it and just do a blanket copy. That should be okay. Then we're simply going to put it into the type table like so. Nice. So the next thing we need to do is say that make sure that the kinds of types are identical. So if they're not equal, we're basically saying that like, yes, this is where the formatting stuff has kind of changed a little bit. So we should really correct that. This is, we've got to be able to say like, what is the type kind and then the identifier when we're printing out these lovely error messages. So yeah, we've got a function called print format, just a custom print formatter where it looks for the special ka-ching sign, and then after that it looks for 2 characters and figures out what to do. So it's context aware. It's context-aware printing. So we used to have, a separate one for structures and enums, but now they're under the same thing. They're a type. So we're just going to join them. So I remember the first time I heard about loop unrolling, and then I went on Compiler Explorer to see what was happening with C code. I wrote, and I was like, damn, this stuff is wild. Yeah. Yeah, there's lots of... Oh. Yeah. Yeah, there's lots of interesting stuff that goes on, like inlining, basically if your function gets inlined, it just opens up the door for so many optimizations. And that's probably the main reason why that function pointers are slow or slower. Obviously you have the indirection, you have to actually call and set stuff up on the stack and that. But there could be quite a lot of like code that literally just gets removed because where it was called from, there's enough context to basically remove entire if statements and just take them out because they do not affect how the code will run at all, So yeah, compilers can do some pretty crazy stuff. I think that's kind of the reason why like shaders are really great, because for shaders, you're writing code and you just assume every single function is inlined. And it just opens up the door for you to just write small little functions if you want. And you don't really have to care about, is this thing inlined, is it not inlined? It does get problematic sometimes though, but it's quite nice in most cases. So we'll have a new one where say $T, TI will be identifier, TK will be the kind. So there's a way to do it. Oh. Type kind strings. We got that? Yes, we have. So now we can say gen.format type kind and just return that like that. So we'll be able to make really nice error messages with that. Type ident, sure. Type version, cool. So we're still keeping the structure field ones and the enum values. They're not still the same. So there's another one called value. Oh, no, it's value enum. Right, enum needs underlying type. So we'll have that there. Dot enum. Yeah, that'll work. So there's nothing else that's specific for enum here. So we'll delete this one here now, since it's all merged under the same one, which is cool. So now we've corrected that print format. We've got to obviously correct every place where we end up using it, but this is the first time we've come across it, I think. Let's look for $. See what we come up with. Yeah, this is the first time. So now we just say $TK. That'd be the type kind. So it'd be strut enum or table, goes in there. And then we obviously do TI, and that'll be type identifier. Is in the database as a this. Please use a different identifier. So this would be the other type kind. So we'll say like an enum with this identifier is in the database as a structure. Right? Don't do that. Format type. Right. This is going to be so much cleaner. So much better. Transmania. I think I know which one you're sharing. Is this the one with Kello, is it called? The Kello library? I think I saw it. I went to feed. Yes. Amazing. I don't know how they're doing the dollar thing, to be honest. I think that must be not. I don't think that's possible, right? How are they doing the dollar thing? Can you have dollar? You can't have dollars in identifiers. That's not a thing, right? This must be some special preprocessor that's surely that doesn't work. You know what I mean? I don't think you can declare with a dollar. I could be wrong, but I'm pretty sure you can't. Compile Godbolt. Right, what was our last testing? Oh yeah, very much. Define dollar crimson. Maybe it is what? Maybe I don't really put dollars in a. I thought that. Maybe it works because it's the preprocessor. Huh. No way. Fair enough. I didn't realize you could put it as the. That's interesting. Just smells of jQuery though, doesn't it? Right, today I learned. Yeah, it basically that var is just basically void pointer, you know? And then it definitely uses like for loop for loops in macros and things, you know, pretty bananas. But yeah, look all this stuff they're doing. It's like there's some wizardry to pull that off. Yeah, so he's declared a macro with dollar, and it seems like you put the type in and the number of elements, and this probably compiles out to like a malloc of like, you know, whatever, you know. It seems like a new operator basically. Pretty bananas. It's interesting, right? But you know, I don't know how much slower it's going to compile your code in. Probably dog slow, or probably a lot slower, right? Because there's all these for loopy things in macro code, but it still might be faster than compiling C++. I don't know. What is this? Yeah, so we've already fished it out. So this one is talking about the dev mode thing, changing your dev modes. So I think we can just do something like this and have a bit of fun. Right, we'll get in there in a bit and sort it out proper. Because this is all enum specific stuff, and we've got some strut specific stuff down here, but we're going to merge the two for loops together, because this for loop now iterates over all the declarations. So we just got to change the source E to a bit of a source type instead. Yes. Now all of this stuff is still a little bit off. This one is saying that Dev mode none. Source type. Right, this is when we up the version. Enter dev mode. Something like that. Well, not up the version. If enter dev mode. Take a complete copy. Right, so make a new type. Make a new type. New type equal the destination type. Up the version. And simply return make destination type pointer be the new type pointer. Cool. Set dev mode. If we have a dev mode, it's not dev mode none. Just use the enum source arrays, as inserting and removing will be too problematic. That is true still today. So this is with enum dot. So we'll make it work for enums, then we'll merge over the structure ones. So underlying type, this is very enum specific, I think, still. Right, type. So these, you know, this is specific for the enum still, so maybe we could hard code it like that. Underline type mismatch, let's be a TU instead, because it's now under the type thing rather than enum. The argument extensions too. Oh, yeah, might have to actually as well. Yeah, it sounds like a lot of macro crazy town going on in there. I remember looking at it before in the past. It was quite bananas. I did learn a lot of tricks from it, to be honest. But yeah. Well, I learned stuff that was possible with the macro system, but I think the way it was implemented was kind of, there was a lot of indirection, and it could have been done a lot more simpler. Which I ended up doing in a few of my code bases, like the for each loop and stuff, the macros. I hate this diagnostic thing. I should ignore these blue diagnostics. They're horrible. They're all the, did you mean? And then it just, they're the worst. Right. Just hop on the functional programming train. What do you mean in regards to the Kello thing or something else? Oh, right, if you're going to use Kello, just jump on the functional programming. Right, so this is to do with the enum. So if the values mismatch, we'll still keep that. Is there another E? Yep. Cool, E. E. Nice. Yeah, maybe we can make these a bit better. I don't know. Right, this is good still. This is good. Final one. Now, we need to put an if statement around these boys and girls because right. Yeah, so this is specifically for enums. But we're going over all the declarations, which is structures, tables, and enums. So, if it's an enum, we shall do it this way. So if the dst kind type kind is equal to a type kind of enum, we'll do it this way. And then if not, we've got the other stuff from the other for loop, which we'll merge in here into the same one. So we'll be able to share all this same. No. Complete blanket copy. Right, it's gonna want to merge the types though. Do we need to merge types? We might have to merge the types over. Right, let's figure this one out. So if it's a new one. Oh, crap. Yes, so if source type is kind is not equal to an enum. There's things like for each. There was a good YouTube video that almost got me converted. Are you talking about like all the filter stuff, like your dot filter, dot map? You know, yeah, I've used that stuff in Rust. It's all right. It's you know, I think the biggest problems with the functional programming is one, to get good code gen, you need to have optimizations on, and it also therefore increases compile times. Two, you need if you need to make it into a for loop later on, for whatever reason, it involves a refactor. Three, you could simply just copy your for loops from another place in the code, which you have plenty of anyway. So the typing experience is about the same. You know, for debuggability is a bit easier. You can put breakpoints down and analyze things a bit better. Yeah. Iterators and stuff, like functional programming stuff, they're kind of alright. But you could just copy paste the for loop. Jobs are good. You know, this for range thing I have, because I do admit this is quite a mouthful. Right, doing a for loop like that is a bit. So I quite like this. I know some people don't quite like it. I like it. Just, you know, go over a range of things. So we need to go over all the. Now I did delete that function called merge type. I think I might bring it back again. Oh, right, we'll go back into Git. Let's get that stuff back out. Right, where are you? Right, this is the one I deleted. Yeah, so what are we trying? but what do we need to achieve? So when you're merging a type, you need to go from one type table to another type table. That's all you're trying to do. Right, so maybe we should call it type translate from one type table to another type table. Yeah, maybe we'll call it that. All right, let's do this. Shouldn't be too hard. Two type tables. Type translate. Yeah, so you get type back out. Type table. Destination type table. Type table source. So the one it's coming from, and then the type. So what we're trying to say is go over the type kind, and if it's a basic type or a packed type, we just return the type because there's nothing to really do. Well, if there's a basic one, I think we can do. We're better off doing like a type table. Get basic from the destination one. Type take source types data. So we'll convert that to an offset basically. You know, and off we go. Rust does it, but yeah, the video I watched did it without chaining. Huh. What language was it in? Was it in C++ or what? Right, so if we get the basic type, yeah, so to translate one of these properly, well, no, it's just got a basic type in there, isn't it? But it's the type pointer is going to be different. Yeah, we could just return type there, that's okay. This one just needs to actually do the lookup. Type table. So the thing is, right, if it doesn't exist, you need to actually put it in there. Yeah. So if it doesn't exist yet, well, when you're doing this merge thing, you should have gone over them in order, which means it should exist. Yeah. So if we just do a find. Right. It's declared below us, so we've got to do that. You know, I've not forward declared anything because I was hoping this would just be a little C file, right? You know, it just does the job. So find in there based on the ident, like that, and return that one. Now, if you've got an array, the array you're just going to make a new type of array, copy everything over. So you make a new type, type init in the destination type table of type kind array. Then we're going to copy the whole thing from the source type. Then we are going to perform the translate on the element type of the array. So ultimately we're returning the new type, but we're going to recursively call the same function, but this time with new type array element type, new type array element type. Right, so that's the new function that we want to be using is that from that merge. So be like destination. So if we end up taking from the encode file and putting it into the database one, we want to be able to sort of like translate it over to the new type table. So this would be DST structure field. Type equals translate. Something like that. Yeah, so that's pretty reasonable. That'll work out pretty well. So then, right, so what else is different from this one here? Yeah, the dev mode thing was the same. We need this for loop in here again. Yeah, okay. So this is all the structure specific stuff. We're going to delete that. Oh crap. Delete that and we're going to bring it. Don't do this. That's right. We'll bring it into here. So now we can get rid of this for loop here because we combined the for loops into one where it iterates over all the declarations because of the way the new type system has been structured. So yeah, just got to do a bit of a rename here from declaration S to destination S to destination type. Cool. Source S to source type. Nice. And now the types have these shared fields, which is really nice. So we can share some code, but they've got their sort of distinct things in a union, right? In some substructures. So these are no longer separate structures now. So we just got to access those. So we strut dot, and we just keep doing that until all the errors are gone. That's got to be corrected. That should be too bad. Right, so just deal with these and we'll go top down and just make sure everything's logically correct. Oh, a whole bunch of merging. It's looking good. What's that fields thing? Yeah. Cool. So let's correct all these errors that we're seeing. So this merge type, where is it up here? It's this new translate function instead. So this is the case when we've entered dev mode. It's easier just to take the source arrays that came from. So for the database, for the type that's in the database, it's easier just to, when we're in dev mode, just to copy the one from the encode file and just patch the type pointers, rather than trying to sort of like adding and removing stuff from the database one, because we're just going to save it all out anyway when this program finishes. So it's just easy just to patch the pointers. Right. They used JavaScript to example it, but they ended up showing how JavaScript does it with chaining in the end. Oh. Interesting. All right. Have you got a link to that video, Crimson? I might watch it after the stream. Give it a gander. Yeah, so currently we've done more than 64 fields because we do some sort of like, we use a bit set to keep track of which fields existed or something like that, and then we can say like, oh, you didn't, you've deleted this one without going into dev mode, so there's a problem. So TITK, so TK would be like strut, TI would be the name of the strut. So that'd be a nice error message. Right out loud, this thing. Right. Right, source type. Crap is this? Seems alright, it's good. Cool. Right, getting there. So after we've done that, we actually go over every single field that we found in the database, and we generate the hash for the identifier, or we fetch the fetch the hash. We go over every single source field inside the database, and we find the field, and then we break. We set in the bit set that we've found the field with the ident. If we found one, we do the merging. So this is where we need to do something a little bit. Nice. I'll click it here and then I'll get it loaded up on my phone afterwards. Alright. Dear functional bros. 500,000 views, nice. Sweet, I'll give that a go. Merged source type. So that'll be a DST. What type's going in there? Source type, yeah. Source structure field type. It's now called type translate, isn't it? Nice. Now we check for equality. Yeah, so we're checking to make sure that the source field and this in the database is the same type as the one in the encode file. So they're already pointers, so it's just like that. And then if not, we change. So format strut gets replaced with format type. Right, getting super close. So this one is, now what's remaining is, right, so rather than these SKs and all that, is T. So we're changing structure to type since struts sit in the type structure now with enums, so they're all kind of the same thing. Nice. So this needs to be source type kind. And same with that one there. And there's still a bunch of S's that I've missed. BTs. Cool. So that is that function done now. So that's a nice refactor. So that's the merge. This is the thing that does all the verification. So the next thing we're on now is the print formatting, and then we can get down to the actual parsing stuff where we parse these struts and these enums, and we should be able to get some code sharing in there as well. Yeah, it's gonna be good. I'm just gonna take a quick little break and get another drink, and then we'll be back to wrap this thing up. I want to get this next function refactored before we go. It looks big, but we'll be able to share more code, and it's going to be much cleaner afterwards. Right, be right back. Right, welcome back, everybody. Ooh. Yeah, let's get this refactor finished up. So inside the print format, which is a lovely custom print formatter, right, this one takes an address of some types, so these are not going to compile. This one looks for an enum based on the enum underlying type. It will print out it as a signed or an unsigned. So yeah, this really saves, makes writing error messages a lot easier having this sort of stuff. This printf is a little bit long-winded, as you can tell, if we did it manually. So yeah, context-aware printing, big thumbs up. Right, so parsing the actual file now. This parses a .enc file or a .enc database file. Just parses strings and stuff. It could have been a tokenizer, but this was quicker. Yeah, this was quicker to do. So, so here's the thing, is we now create a thing called a type. So I guess I could replace S with type. Yeah, so I'll just call like type init. Pass in the address to the type table, or just the type table, because it's already an address, and we have type kind of strut. Now, we don't need to zero it anymore because it is zeroed. The location though we will set manually, and we don't need to set the fact that it is a table anymore. So really this should be if is table type kind table or that. So, you know, we read the ident, chuck it in there, verify the identifier, make sure it is an identifier. This does some parsing of those directives. Now this is going to be shared between the enums and the structures. There might be some that are very specific, but I think they're basically going to be the same. So this is part of the reason why I wanted to do the refactor, is to just make this a function, because it's just silly. So parse decal directives, type table, maybe just put the type in. Yeah, type, and probably the text reader. All right. So all it's going to do is do all of this code here. So it's quite meaty, I think. It parses the dev stuff and it parses the version as well. Depending if we're in dev mode, sorry, if we're the database or not. So there's be another one, is database file. Should be all right. So yeah, well, I guess we'll quickly go over it because, hang on a minute. What the living, what just happened there? The selection clearly went a bit crazy. What the crap? Yeah, okay. The reason why the selection messed up is because Helix is not parsing strings when doing the thing. It's got this LSP thing, but it can't do that. I don't know. Sounds like you don't need an LSP to do that either. Maybe it's not using the LSP and they've not implemented it right. Well, there we go. Right, so it's actually passing via a pointer into this function, so just got to do a quick little rework of that. So yeah, we just say while there is this hash, we're passing those directives. So a quick little, you know, parsing like these things here, right? Version or the dev thing there. So, you know, if it's got dev, we then parse the arg and then check upgrade or no upgrade and write the enums out. If not, dev mode, blah, blah, blah. So it's saying like strut with the thing, right? Yeah, I guess we'll just use the structure one like that. Even if it could be an enum or a table, I think that's okay. Yeah, that'll do. Cool, so got a lovely parse directives thing now. I should be able to give that a go. Someone's trying to sell me Helix at the conference 2 weeks ago. Right. It's quite good. You know, if you've not got any of them set up and you're going to, you know, you're gonna want to get into the modal editing thing, I think it's great for those people. If your NeoVim crashes and you can't be bothered with NeoVim, I also think it's great. But if you got NeoVim, I wouldn't think switching over is necessary. If you already got your NeoVim set up and you like it. But yeah, I do think they've got some things to do in it though. Like it heavily relies on the LSP for things, which I think could just be simple string stuff. But I do like the config file, how it's just a config file, not a programming language. You know, pretty nice. Right, there's another one with this versioning thing as well. So I think we pass the directives after the identifier in it. So reader type, so it's just S, and then is DB, is the database. Then this goes to put it into the type table, right? So this is where we could probably say type table insert decal. Then inserting a decal is a little bit more hands-on. Might try ZIDE, but neither of them is pretty good for me. Cool. Yeah, it did look pretty cool. Does it put the reader and stuff like that in it? Yeah, I've got like the reader in there and everything. Just I'll just call it parser insert decal, whatever, right? Put the type in there and off you go. So address of reader and S for the type. Oh, we need the is database as well, obviously, because the database behaves a bit differently, deals with versions and things. Right, so with this one, we don't need this type declared locally. Right, so we find the type in the table. I need the type table too. So right, so with S, the S is basically S. That'd be type. Alright, it's looking okay. Have a bit of a gander though. So reader obviously needs to get rejected. So rather than a pointer, it's already rather than taking a pointer, it's already a pointer. Alright, type dot kind. Okay, so other S. We'll change that to be other type. So what does this code do? Well, if you're in the database and you've parsed a type, so in the database, right, you can have the same function, same structure declared with a different version number, right? All we're doing is basically saying if you've picked up a version 1, make sure you put it at the top of the linked list. If you pick up a version 0, put it at the bottom, right? And if you pick up a higher one, it goes at the top of the linked list. So whenever you go into the hash table and you get back a type pointer, it's always the latest version of that type. So all this code is basically doing is doing that, where it's going to yeah, if it finds the type, make sure they're the same things. That would be a gen dot type kind. Duplicate strut identifier. No. Duplicate, it's just a duplicate identifier. Yeah, so this already exists. And as the found type. Other type is going to be a type. Right, so if the version is less than, yeah, I've already checked this and it works, just got to refactor it. Yeah, so S is going to be type. Right, this is saying if it's the root one. Right. If this is the root one, yeah. So if this is the root one, we've actually got to insert it over. Is, you know, found the latest version, insert at the root. Insert as the entry in the hash table. So effectively you get this DST is equal to type. Yep. Cool. That seems all right. Okay, so now this code is shared between structures and enums now. So we actually have another piece of code which looks exactly the same, just a little bit of a rename. Right, so I got the version there, so I can just tidy that up a bit. Duplicate strut. I guess we say $tk for type, $ti for identifier, and then $tv for version. So I don't need any of that stuff there. Cool. Now this is if we're not in the database and we just insert, we've got duplicates. It's just a duplicate identifier. There's this same error here. Probably join these lines, to be honest. Just make it a little bit more compact. That's a good point. This needs to set this one here. And then we could probably, for the context we're printing to be correct. Nice. That's a lot nicer. Okay. Right, so we've got this reusable function now for the enum when we get to it. But let's just keep going with the changes. So back to parsing the file, we're parsing the strut, we've done the directives and the insert and the decal into the type table. So after we insert the decal, we parse the actual contents of the structure. So we just got to give these a little bit of a rename. You know, we don't have separate structure types anymore because it's all just in this type instead. So just going to plop these down where they make sense. So this one's saying if this is a strut and the structure field type is a table, we have a problem now. Oh, we have to say that the tape. So we'll fish the table out. So that'll be structure field type. Nice. And we're just going to say strut type this cannot have a table in it, since the strut is fixed size and the table is variable sized. So we'll just do that. Really, that's fine. What's the next one? Right, seems pretty reasonable to me. Give those a rename. That still seems good. Right, so this is when we get an array. So after the identifier, there is array literals. So these probably still would like to. So it's the array type. Use the new type initialize function, just pass in the type table, and then say it's a type kind array. We don't need to zero it anymore, but we definitely set the element type. And structure field type is then equal to array. And then the rest should just be quite straightforward. So the array dot elements count, or VLA identifier for the variable length array. What is this? Yes, we go over all the structure fields here, and we look for an identifier. That's in string equality checks. They should be hashes at this point. So we could do string hash checks as well. But that should be fast enough. Well, we could change it outright. We might as well while we're here. So we just hash the ident. Don't know if that's going to be used as a hash, is it? Let's call it a hash, maybe. VLA ident hash. Core string hash. Array. VLA ident. So you hash it up. Then we check. So we push on here these filled hashes. So we can just simply do a comparison now. VLA ident hash. See if they're equal, we've found it, and that's a bit quicker, so it's not doing string compares. Hopefully, well, it depends how many fields we're going over. No, it should be. Yeah, as long as it's not like one field, it should be quicker. So found, yep, that's all good still. This still reads okay. Right, so that's still good. We can keep going. What is this? Some more directives, but this is specifically for structure fields, so we'll leave this one here. And we're there. That's it. So that is the structure one done. Now the next refactor is the enum. So this one will follow the same suit basically, but it's a little bit easier because there's less stuff. The enums, right? You're just parsing an enumeration like this. So we've got this directives thing now. And, you know, fields, enum fields are a little bit more complicated because they're a type. Sorry, structure fields are more complicated because they're a type, an identifier, and directives, whereas enums are just identifiers and a integer value, so they're a lot easier. So hopefully it's just a case of just making sure this code compiles. So the base one is always signed 32 int. You know, we read the identifier, then there's this underlying type thing. Is this your own IDL? What does IDL mean? But probably the answer is yes. So I've got my own description format for structures. So we could do like versioning and code generation. You know, this could have been done with like macros or could have been done with generating type tables and stuff, but I want to have like a system where there's like a database of all the past structures as well that gets retained, and code generate the encoders and decoders. So yeah, it's an encoder and decoder system, and it's a custom description fit interface description language, I think. Right, okay. Yeah, it's like a data description format. Yeah. So yeah, it's got a bunch of rules, but the rules are managed by this encoder generator. So if you change something you're not allowed, the system's going to be like, you got to put it into dev mode if you want to make the change, and if you put it into dev mode, it will up the version number, right? So it forces a version change. So stuff like that. It will support serializing out to text, binary, and also in-memory packing and unpacking. So it should work for networking, files, and GPU stuff. So yeah, it's got quite a broad range of use cases. But it's going to be used for the editor. Yeah, it's going to be pretty useful. Parse basic type. Did we get rid of this? I think we did. So I think it's called parse intrinsic now, isn't it? Yes, you parse intrinsic, then you check if it's basic, and if not, error. Yeah, so you parse that up, then you check to make sure that type is basic. So we've got that new lovely function now. And if it's basic, yes, if it's not a basic type, as in like an integer or something, then we say that's a problem, and then we just fish it out here, type, intrinsic type, basic. Oh, right, so this is those directive things. So we've got a function for that now. It's actually just called parse directives, passing the address of the reader, pass in the type. So it's E for the enum type. And then is database file. So this can all go now because this is basic. Well, this is the same. Apparently interface definition language. Right. Yeah, I guess so. That just makes sense. Version numbers, yep. Right, then the one after that is the versioning thing. Right, inserting it into the type tables, but also versioned. That's parser, insert decal, reader, type table, E for the type, and is database. So it can behave slightly differently. Well, yeah, if it's parsing the database file. Cool, so now the rest is basically just, it's one of these errors, just doing this sort of like enum underscore thing, because it's now this joined type. It's all in one massive type struct rather than separate type structures and being in different arrays. So it should just be a lot easier to maintain basically and be less scruffy. I think we're getting there. Nothing's going to change in these. It's basically just parsing the identifier and the value and making sure there's no duplicate value. This is a bit funny. We're going over all these. If there's a if there's a duplicate, but I've already got a thing for this. So I can just do something like generate a format type equal E, and then format value EV, I guess. Hey there, Degrad Bill. Welcome. How you doing? Welcome to the stream, sir. Are you going to manage the different versions so you can maintain backwards compatibility? Exactly. So we keep the previous ones and we have like the generator won't do the upgrading. It will generate the code which calls all the upgrade stuff correctly, but to upgrade the individual structures, that's the job of the user. Obviously, right? So yeah, be able to upgrade. So if we load in a file with a previous version, we will store the type information at the top of the serialized data. So we'll be like, oh, there's a structure with this version in it. So it's a different one. So go and upgrade the whole bit of data and then deserialize it with the latest structures, basically. So yeah, it's going to be pretty powerful. And that's the reason why I wanted to do it now, because we're going to be building editors. So I want to make sure that A, we get to test it out, and B, we don't have to refactor everything. So then by the time we actually produce content with it, it's going to be tested out and I would have found some problems with it and fixed it, basically. So, and then I don't have to go and do it later on. Makes sense. Time to make a linter to say how to upgrade it. Maybe. I just have to. It will just declare a function that it will call, and it will just say unresolved linker error, and that's pretty much self-explanatory from there. Did you write an assembler for your compiler or you got? Yeah, so basically there's a thing you target which is called SpearV for GPUs. The spec is really great. Just it's really great, easy to read. It's a great format. So all I did, most people end up using like the SpearV library and it's all in C++ and stuff. But the format is so simple. You don't even need to use all the libraries. You literally just can just go through this and just do it all yourself, right? You can think of a SPIV file as an array of 32-bit integers, and it's like super easy to like make your own. So, there's one or two things about it which is a bit annoying, but besides that, it's quite straightforward. And you can just emit your own. When you have a source language, you can just load it straight down into this. I think I have my own IR though. That's cool. I'm pretty bad at English too. It's my only language. Yeah, like I always say to people, please bear with me. English is my first language. You know. Rust added a new feature to toolchain that you can call that informs you how to update your code to the newest edition of the compiler. Interesting. So, Rust has breaking changes? Is that what you're saying? Crap. I guess put EV in there. And then this could just be all in one line because it's going to be super awesome and straightforward. Yeah, so it's going to do something like a value, and it will just work. None of this if statements will be needed because it's all done in the formatter. Right, so that's nice and cleaned up there. It's pretty cool. That's all right. So I got this commented out code here, which I'm saved for the future. So when we do the generation side of things, we're just going to nick some of this and code gen everything we need. But that's, and there's the binary one as well. Right, so we've got to change the save database stuff as well. Let's quickly get to the top. Go to the next diagnostics. Right, what's that one saying? Unused parameter type? Damn it. These S's. Right, that was a good diagnostic. Thank you, diagnostics. Save database. Right, this is where we've got to do the save database file now. Oh, it's Laurie. Hey, Laurie. In Rust, there's breakages, but they're done through additions. Yeah, I remember now the 2021 one I think they had. Which means your OK still compiles right. Crates need to specify their addition. That just sounds like things are going to break hard. Because you won't be able to... Oh my days. So it might be very hard to update to a new edition, and therefore you're stuck on an old version unless you re-implement a library, right? Oh, wait. So you can have a 2021 package working in a 2024 package. but not vice versa, right? Because the new edition brings new functionality, right? So we'll be able to go backwards. Yeah, I would. Yeah, maybe. Yeah, looking at old C code is going to be scary. How can you have backwards? What's the point of additions then? Because if you can have forwards and backwards compatibility, then what's the point? Because surely, well, so they never remove features. That just sounds weird. Like, what's the point of an addition? If you're not going to change the language, then what's the point of an addition? I don't get it. Right, so here with the saving the database file out, right, just re-encoding it back out as text. Proper easy peasy stuff. The problem is it's not going to be in order. So we've got to solve that order problem. I was hoping to get to it today, but we've just been doing the refactoring, to be honest. We've done these two. We still need to do the amend one, to be honest. This one here. All right. So we should probably go and save out all declarations, and then we'll probably have a boolean to say like on the type. We'll have a little boolean field to say like is saved. And that defaults to 0 because it's all zeroed. So I think we'll just have a recursive descent, sort of like save type, right? File f type. So the whole point is you go if type has already been saved, return early. Then you say type is saved equal true. Then you want to recurse, you want to say if it is an enum. No, if it is a not a decal, maybe say save decal. Yeah. Save type decal is declaration type kind. So it's not a declaration, we're just simply going to return and not bother saving that one out. Nice. Goes on to avoid segmentation, stagnation of the language or standard library. If someone's random company's 10-year-old code still compiles, us break and change, nobody's angry. The new people can always use the new shiny stuff. They add features with new additions and rarely take stuff out, but treating them as a separate compilation step, meaning you can compile the older versions against the older features and still work with the new stuff. Yeah, but then how do you have forwards compatibility, right? So if you compile for Rust 2024, right, you use the new features in Rust 2024. So if you go back to, so if a language with Rust 2021 compiles that function, what happens? You get an error, right? Or does it never compile that code? So we're saving a type. This is where we... Right. So we want to say if it is a struct, if it's not an enum. Then we need to go over all the fields. And we need to save out those types if they've not already been saved out. And then that way, it should... it should... Yeah, maybe we should link list over all the versions as well, you know? Yeah, that's another thing as well, is I want to put... Yeah, so we should save out the decal type. For the structure field type. So I think we should go over all the versions and save out no, we won't do that. Right, let's just say save out all the type strut. Right, so say, because things have to be declared in the right order, to fix that problem, we're just going over all the structures beforehand and simply just saving those out. So I think now we simply just say if, right, I guess this would be if it is an enum. If it's an enum, we want this code here. Yes, if you want to use the additional features that exist in the newer versions, you have to update your addition to match, but the code remains named the same. We'll get the benefits of the new version without having to update. Right, okay. There's backwards compatibility, but not forwards compatibility. Right? Because you can't take... Yeah, I see. Yeah, so you can't... So if you have a Rust application, which is in edition 2021, and you include a library which only has edition 2024, will that work? You get force compatibility if things are named the same. Right, so the compiler still compiles the 2024 code. Because the compiler can compile it. Right, I think I see what you're saying. So the compiler can compile 2024 and 2021 code. You can live in 2021 land. But, yeah. Right, I see now. So it'll still be compatible. Right. Huh, did I not take the... Oh, I did that in the totally wrong place. Right, let's move this out of the way. Right, gen type. Gen dot type. Type. Righty-o. So I'm going to print out the enum. So type version. Nice. Print out type dev mode. Prepare the dev mode flag. Maybe this could be shared a bit, but oh well, it's not that big. Right, type. Nice. That looks pretty alright. So there's the other one for the structures. These are a little bit more hands-on by the looks of it. I can make that a bit cleaner, to be honest. Right, so I'll put a comment here to say, you know, save out the fields types just in case. Types are parsed in the right order. Right, there we go. Then, so if you get the hash map create date 2024 and change how new, you cannot. Yeah, I see. Right, I think I see what's going on. So they can only add new features, basically. They can add new features, but not take away any features. Damn it. Type, that was it. Right, type is table. We don't need this crap. We've got our new thing now. Type kind, type identifier, type version. Then if dev mode, we put the dev mode thing in there. Easy peasy. Go over the fields and emit. Right, if it's table, we want the default value. Because tables have default values. Emit. Cool. So the final thing is that we want versions, right, to be in the right kind of order. So you'll be doing the greatest to the least version, I think. So what we'll do is we'll say if type next version, we'll call into this one and say save type decor file type next version, right? So that will then save out the next version recursively. So there's a bunch of recursive descent stuff, but there we go. So that'd be pretty cool. Right. Yeah, I think we've got a bit of an issue with... I'll think about it some other time. Right, so Now when we save out the database, we simply go over all of the types that we have in the database, and we simply yes, this one we're saying if the type has a previous version. No, has a next version. If it has a next version, we're not the latest, we're gonna continue. Because we want them to be printed out in a nice order. Right, we want to be printed out from high to low. So yeah, so skip old versions here such that versions are stored in a high to low order by recursive descent in save type decal. Right, and then we'll simply just call save type decal in here. Nice. Cool. See, I think I thought of a bit of a problem. Wait, is that all compiling now? Yeah, apparently it's all compiling. There's no more diagnostics. I don't know if it's listed here. Yeah, how do we handle if a strut has changed version? Yeah, so I think this is another thing as well, is like, that I've not really thought about, is if you have an old version of a structure that uses an old version of another structure, it should probably have that in the declaration or something. So we should probably handle that. I gotta be careful though. Yeah, I think we all need to do it. Old. Yeah, and this points to another kind of question. I need to think about this one. Why don't you use a serialization library? Because I want it to work for GPUs, and I want it to work for... Well, one, I want to build my own thing. I want it to have like versioning, text file, binary file. I want it to work for networking, encoding to go over the network, encoding for files, and GPU encoding and decoding. So it's an overall system to sort of like just deal with encoding and decoding stuff and automatically generate packing code based on like stuff like this, basically. Yeah, GPU realization, that thing. So yeah, we'll be able to easily declare a structure and just be like, take this U16 and pack it down, and have things all bit packed, and not have, because I was doing it with the BVH node, and it just wasn't. Yeah, it's very error prone basically. So whenever I do any of that stuff now, I want to have the ability to do it without making any errors. So this system will help with that. So things will just be nicely packed and be able to unpack them with a breeze. So yeah, solving like many problems with an overall solution. Yeah, that's the plan. Right, so I think we saved some lines of code. I don't know what we did, maybe. Yeah, the code base is generally a lot better now after this change. Happy with that. So I've got to think about this one problem though. Let's go to the encode database file. This is a bit of an issue. So if you have a level 1 and level 2, or I think we should really try and think about this one. How do we handle if a structure changes version and is used by another structure that hasn't changed its version? You know, so we change the entity structure. You know, the version gets changed. Yes, if the version gets changed, you know, they'll no longer be ABI compatible, isn't it? So that means you might have to force change all the ones that depend on it. But so we're only doing this versioning system for files. Networking is not going to use it, GPUs are not going to use it. So the way we could do it is that we simply say that we could probably code generate a function which has the upgrade thing in it or something. And the idea is you get whenever you have an upgrade function, so there'll be a bunch of upgrade scripts that run. I think it sounds pretty reasonable. You'll get a function labeled something like entity, whatever the name is, right? Upgrade, or, you know, v0 upgrade v1, or whatever it's called, I don't know, to v1. So there'll be like an output add another level of abstraction to make a schema for this that converts between versions. What? What? I'm not sure how that... Isn't like collider like XML? So I think the basic idea is you'll be able to read your fields in. See, this upgrade code, I don't want it to be error prone though. See, the better thing is if it's a structure, if it's two separate structures, you'll see them in memory. And you can make your changes and it will just be better. But the other way, right, is you can say like, you know, read field, whatever it's called. You pass in your arguments and you read your field. Maybe you do it as a string, or maybe you do it as like an enum or something, right? And then you write, and there'll be another one where you write, you know, maybe you change the value, and then you write the field back out via another silly function, right? So you can get around it that way, and you wouldn't have to have versions. So if you change the version of a strut, you wouldn't have to change the version of all the parent ones. But then it's kind of implicit that you're knowing what the previous version actually was. So I think this is really just a bad way of doing it. So I think when you do this, you should always have the entity encode v0 and the v1. So you have your old and your new. Or your from to. And this will mean that you can then work with actual types, and the system can just do all the re-encoding for you. Cloud uses XML as a schema to define the data, and it transitions between different types of data, so they can convert between Blender files and Autodesk files. Huh. Right, so because we're going for that idea, it does mean that structure changes will have to impact, right? So we'll say, so if you so it is a bit annoying if I put a function, or if I put a strut into dev mode and change the version, it also means that all of the other structures that use it recursively are affected. And those ones do they go into this sort of like dev mode? So they'll go into this sort of like dev mode thing, and then when you bring it out of dev mode, I think when you bring it out of dev mode, it will go up and chase everything and change the version. And then it could probably, the problem is the upgrade function could probably be automated at that point. So the code generator could define that one, where you could say it's an auto-generated one or something. It's a bit hands-on though. Invalidate the nodes recursively, yeah, so when we up the version of something, like we could get it to auto-generate. Like, you know, you would say like, put it as, you know, this might be marked, you might be like, well, you're a V0, but you're a V1. And maybe you could say this was auto upgrade or something. So if it's marked as auto upgrade from V1 or V0 or whatever, it's going to yeah, see this, the whole idea of the versioning system is quite complicated because it introduces this stuff, and that's only if struts change. Whereas tables are allowed to change. They could be added and removed, but you can't put the same field back in with a different type. Maybe we should... I got two options, right? We could do the upgrade thing. Or we could have the hard limit that structures don't have upgrades, because it adds quite a lot of complexity. No, what I'm saying is the level has to update because it contains an entity which updated. It's the other way around. Yeah, that's right. That's right. So because it's an auto upgrade, it was copy it. Yeah, this just seems complicated. Maybe what we do is we remove the versioning thing. Play around with this idea for a sec. So if we remove the versioning thing, we've got, if you put stuff as tables, you can just change them. Structures are fixed in stone, but structures you basically use for networking. No. Or fixed types that never change, but then like, yeah, I gotta have a think about it. Because the versioning thing does add a lot of complexity to the code. Yeah, I'll have a think about it. Things to think about. I think versions could be vital though, because you will make changes, things sometimes. So we just got to find a way to do versions that are not complicated and have a very straightforward way on how to do it. But maybe we don't make, maybe versions, maybe let's say versions are rare, but when you do them, maybe they're a little bit more involved. I don't know. Yeah, we'll see. But yeah, right. Does the level care how the entity is defined? Though all it knows is holding something called entity, or is that you will destroy it? That will destroy your data offset. Yeah, so I'm thinking about doing all these things in line. So yeah, the upgrade's in line, but maybe actually, maybe all that matters. Yeah, maybe it doesn't, right? Maybe what we could do. Yeah, we could say all because the type information is stored in the thing that you've serialized to the resulting binary. So the level structure has stayed the same. And the entity is different. It does matter though, this is the thing. It's the upgrade. That's the problem with it. So remember when I did this? When we have an upgrade function, I want the user to be able to upgrade from V1 to V0, and if the entity has a structure in and of itself, right, you need to know the version of the structure that was being used inside the entity, right? Because, so that's the reason why I wanted to use hard-coded types, so you could achieve that. You could try a binary auto upgrade. Yeah, so that's the thing, is you would do the auto upgrade for all the parent types of the entity, like the level. That could work. Then if both things change, that might be a problem. I'm not sure. Yeah, non-compatible versions, we will have a way to do no upgrades, so there'll be a way to break the changes and it will default or be zeroed. I'm not sure what an NSP file is, Cloud, Evan. Sorry. How are you unpacking the entities in relation to levels? Are you storing them packed together, or levels is just an offset? They're all packed together. They're in part of the other type. Yeah. I'll have to have a little bit of a think about it. Right, I really got a jam now. But yeah, thank you for coming, everyone. I'll commit this code now. And yeah, so on Sunday we'll carry on with that to-do list. So we've still got still these things to do, like hash amend and put git hashes in there maybe for future purposes. But we've got some of these to-dos as well to fix up. But yeah. So when these are all done, we can actually get to the code generation side of things and get things rolling. Right, it's first on to raid if there's anyone on. Right, let's give Kanji a raid. Right, have a good weekend, everyone. I'll see you all hopefully Sunday. And might be easier to group entities into a packed location instead of the levels just offset into the group. And how badly it would affect cache locality though. Right. Yes, have them in a different place. Yeah, also change how the serialization code might work as well. But I see what you're saying, like put them in a different... Yeah. Yeah, have a think about it. Thank you so much. Oh, let me just pasted a bunch of crap into chat. Right. Catch you later, guys. Have a good weekend. Bye-bye. Bye-bye.